Welcome to your quick lesson on ionic bonding. Ionic bonds form between two or more ions. Attractions occur between positive and negative ions. Notice in this example you have magnesium with a 2+ charge next to a calcium with a 2+ charge. No attraction between these two positive ions will occur, and in fact they will repel each other like two positive magnets. But if you put magnesium with a 2+ charge next to oxygen with a 2- charge, attraction between the positive and negative ion will occur and bring them together. In this example, we have a sodium atom next to a chlorine atom. Sodium is in the group 1 alkali metals, so it has 1 electron for its valence electrons. Chlorine is in the halogens, so it has 7 electrons for its valence electrons. In order to form their octet, sodium will transfer 1 electron to chlorine. Sodium forms its octet by losing that 1 electron, and chlorine gains its octet by taking that 1 electron away. Because of these transfer of electrons, sodium will form a +1 charge because it lost 1 electron, and chlorine will form a -1 charge because it gained 1 electron. We call ions with a positive charge cations, and we call ions with a negative charge anions. Because these two ions have opposite charges, they will be brought together through a process called electrostatic attraction. And basically it's the same idea you're used to with a positive and negative magnet being attracted to each other. We can use these two ions as an example to write out a formula. In order to do this, we draw a balance. On the left side of the balance, we write our metal, which happens to be Na with the positive charge. On the right side of the balance, we put our anion, which is chlorine with its negative charge. Below each side of the balance, we write the total of the charges on each side. On the left side, there's only 1 sodium. Since it only has a +1 charge, the left side is going to equal a +1. On the right side, there's only 1 chlorine. Since that 1 chlorine only has a -1 charge, the total on the right side is a -1. When we look at the numbers, they have opposite signs, but they are equal to the same number. If you add these numbers together, they will total 0. If they total 0, the charges are balanced. That's what you're always consistently looking for, is that the charges will cancel out. Because they are balanced, we can put them together in a formula. We get rid of the charges and we bring together how many different atoms we have. We have 1 sodium atom and 1 chlorine atom, so we can write them in a formula as NaCl. Because the charges balance out right away, the formula just becomes 1 Na, and we write it as Na, and 1 Cl. We can then even take this one step further and name the compound. On the periodic table, Na is called sodium, so we would write the name as sodium. Cl is chlorine, but because it's the anion at the end, we have to actually change its ending to chloride. So this compound, NaCl, we rename as sodium chloride. Another example would be with magnesium and chlorine. Notice that magnesium belongs to the alkaline earth metals, so it has 2 dots for its Lewis dot structure. And chlorine, again, is in the halogens, so they each have 7. There are 2 chlorines because magnesium is going to give away 2 electrons. But each chlorine can only fit 1 electron into its octet. In this case, magnesium gave away 2 electrons and it enabled it to complete its octet. Chlorine, each one gained 1 electron, so each of the ones gained their octet in the process. Because of that, because magnesium gave away 2 electrons, it now becomes a positive 2 charge. Each chlorine only gained 1, so each gets a negative 1 charge. Again, we call magnesium with a 2+ charge a cation, and each of the chlorines with a negative charge are your anions. They are again going to be brought together through electrostatic attraction. Just like magnets, a positive charge with the negative charges are going to be attracted. And now we can practice putting this into a formula by again drawing our balance. On the left side of the balance, you write your cation. This one happens to be magnesium with a 2+ charge. On the right side, you write all your anions, and we're going to write the chlorines as separate parts. So you have a Cl negative and a Cl negative. On the bottom of each side, we're going to write the total of the charges. On the left side, since there's only one magnesium, the total is going to be a positive 2. But on the right side, since you have one chlorine with a negative 1 and a second chlorine with a negative 1, you add the charges together to get a negative 2 for the total of the right side. Now, looking at the number of the charges, you have a positive 2 and a negative 2. If you would add those two numbers together, again they would equal 0, so this shows a balance of the charges, which is what you're looking for in order to write your formula. Now, when we put these together, we have to write them in a formula that shows that we only have one magnesium, but on the other side we have 2 chlorines. So instead of writing 2 separate chlorines for your formula, you're going to put it together as MgCl2. That subscript 2 signifies that there are 2 chlorines attached to your one magnesium. Now, similar to our last example, we're going to name it. Mg on the periodic table is called magnesium, and we don't change its name. Cl is called chlorine, and again, we're still going to change its ending to an IDE. So the name would become magnesium chloride.